It is Sunday today, and I am not sure if I'm going to be able to get down to the shed tomorrow to work on the Harlem Globetrotters table. Uh, but I have been working throughout the week, and I thought I would make a quick video talking about the process of creating the software that drives the LEDs. I've made another video like this in the past for another table, but I thought I'd go into a little more detail about what is required to figure out where all the LEDs are on the table and to figure out which numbers the Bally machine is putting out when they want to light a particular LED, and then match those two things up. So when the Bally puts out a number like 22, I know that it should light up the outlane bonus light or whatever. Anyway, I'm making all that stuff up. But the basic idea is you have to do a mapping of Bally's digital codes to the actual physical location of the LED in the string of LEDs that we installed. So to do that, you have to go back to the schematic and take a look. But before we do that, I had to run down to the shop yesterday to pick up the microprocessor so I could reprogram it to do a little test. And Mike had set up the pinball machine to just to test it out with the pop bumper caps on, and it looked so good I just had to film a little bit of it. So here I want to show you what that looks like. Here is the table with the pop bumper caps installed. They really look awesome. Sorry for the portrait mode filming, but that was the way I was holding the camera, and it switched that way, and just for this I thought it would be okay. So there you go. The table looks really good in my opinion. After I reprogrammed the microprocessor and brought it down and hooked it up, I had programmed it to just step through each of the lights one at a time so I could figure out which number light each LED was. Normally Mike and I do this together, where I'll step through and tell him I'm on LED 5 and he'll write down which light it is and we'll be all done. But since we are working separately because of the situation in the world right now, I have to kind of do this myself, and I figured the easiest way would be just to film it running through the entire sequence. So I would just go back and look at which light was on, and I would figure out where they were and just record them myself. I did make a mistake. I'm not going to let this play through to show you to the end, but I only set up to test 100 LEDs, and apparently there's about 102 or 3 of them. So I missed the last few LEDs, so I'll have to do that a little bit later. But finding out the index of this, like I said earlier, isn't the whole job. The other part of the job is to figure out what Bally is sending out when they want to turn on one of these lights. So like, let's say they want to turn on this light right here. What code do they put out to do that? This little test I'm running here will have identified what the number in the string of this light is, but not what the number that Bally is putting out. So I have to figure that out from the schematics. So let me show you what I had to do in order to figure that out. Okay, behind me here you see a schematic of the light driver board from the Harlem Globetrotters table. I got this out of the manual that was on the pinball database. I forget what the site's called, but I downloaded that. I saved it off as an image, brought it into GIMP so that I could edit it and add numbers to it, and now I'm going to show you what I've done. So to start off with, you guys have probably seen this before if you worked on pinball machines at all, but Bally uses 4 address and 4 data lines to latch in the state of LEDs that will get lit up, and so as they're strobing this in, um, the four address lines come in and get latched into a 4 to 16 decoder, and each data bit enables a different encoder, so that lets you latch all of the bits in. And address 0 on this top latch, or top decoder, sorry about that, is address 0. And over here on the side, you can just barely see where I edited in and I put address 0. So when the microprocessor puts out address 0, bit 0, and sets that to a 1, that 0 bit turns on. If the 1 bit is turned on, then this 1 turns on. If the 2 bit is turned on, then somewhere down here, the 2 bit right there is turned on. And you have to follow these wires back through and trace them back through. It's really, it's an eye test. It really is an eye test, because you get crossed all the time. So you got to be really careful in doing it. Anyway, and then if the 3rd bit is on, then that's a 3 down here. And then 4 comes back up here. So I had to step through here and trace each of these out and number these to figure out what each number is. One of the things I noticed is that the same player shoots again goes to both the back glass and somewhere down here to the table. Right there it is. Same player shoots again. So so I drive that with 2 separate lights, so I will need to have a little fork in my software that says if they send out, if the Bally processor sends out a 42, turn on this light and turn on this other light. So, but that's easy. I have code all set up to do that. It's common on every table to have something like this occur. So once I've got this documented, then I have to record it and make it orderly, and I use Excel to do that. So let me show you my Excel spreadsheet. Okay, over here on the left of me, you can see the table that I created. Raw numbers on the right are just 1 through 61, which are the number of controlled LEDs that they have out there. And on the right here is the number that I recorded of what that is. So the 1K bonus was 0, the 5K bonus was 4, the 9K bonus was 8, and so on and so forth. And once I have that all recorded and all of those, make sure I don't have any duplicates, then I just use Excel to sort this. And there is the order of what the thing is sending out. And you notice that once you get this in order, it makes more sense. 1K, 2K, 3K, 4K, 5K, 6K, 7K, 8K, 9K are all in order, and you know, as are other things. And I looked through here, and the only duplicate I found was the same player shoots again 42. I didn't see any other duplicates or any missings, so I think I have done that correctly. So now the next thing that will have to happen, and I haven't done this part yet so I can't show you, is I will have to go through and find out where the 1K bonus is in my LED string. So that part I showed you at the beginning where I was looking at the LEDs and what order they were turning on at, I will record that order in this column. So if the 1K bonus is the 15th LED, I'll put a 15 in there. And then I can take these 2 pieces of data and I can insert them into my code that drives my conversion program. So it seems like a lot of work and a lot of difficulty, but it's really not. I mean, it's pretty simple. It only takes a little while to do. The hardest part is tracing out those wires. So that's it. I'm going to leave you here for now. And when I get the table filled in and uh, the programming done, I might do a part two of this where I set up the software and show you how I bring this data into the software. I am planning on building the board that's going to go into the table this week. Mike has ordered some new processor board and new relay driver board, I believe, for the table. So we should have a working set of logic. So once I get this thing programmed, we should be able to put the table together and test it out. So I'm looking forward to that. So thanks for watching, guys. One thing I forgot to say that I wanted to mention was that Bally uses this light driver board in almost every one of their solid state tables, at least in the era of tables that we're working with. And the schematic is almost identical in every manual. The names change because it's going to be bonus 1 through 15 or something instead of 1 through 9 and whatever. But the layout of the wires and stuff in the schematic are all the same, and 0 is always there and 59 is always there. So I can reuse this numbering system, and when I did this, I did it in GIMP on layers, so I can change the schematic layer and just move the numbers over to whatever the next board is, and figuring this out will be a lot quicker. Now there are some that aren't used. They might have swapped. There's like sometimes they go a line goes to two places. Like this line right here is the 3x bonus line, but it could also go to the back box as something. So depending on the game, they might have chose to take it one place or the other. So there might be a little bit of work to do, but it's not bad. And you know which number it is. It's regardless of whether it's there or there, it's 45. So I'll be able to use this over and over again, and it'll make the work a lot quicker. Well, I thought I was done recording, but as I was continuing on with the work of figuring out how the LEDs are indexed, I ran across something kind of interesting I thought I should show you guys. So let me take you over to this other screen here. If you look at J2 here, right in the center of the screen, you can see on the right there it is very clearly labeled to backbox. And so to make it easier to lay out, since I'm only laying out the play field, I figured I should be ignoring all of the signals on this connector for now until we have the backbox wired. So I took my spreadsheet that I was building and I highlighted in pink all, or actually I highlighted in green all of the connectors that were on that J2 connector. So over here on the right is the indexing of the lights down the playfield. I went through and I counted the 0 through 99 that was actually there, and I think there are 2 more that I missed. So I just stuck them in there for now. There might be another one hidden away someplace that I don't know about. It's minor, and I'll figure that out when I redo the test. But for now, this is enough to work with. So I started mapping these one to one, and I came to things like the 10K bonus here. Now, the 10K bonus is on the playfield, not on the back glass. So same thing with the center G. So I started looking around and I noticed something in the schematics. And let me see if I can pull those up real quick. this is the schematics of the playfield, and if you track the wires um, from J2, they come up to this area right here, and it appears that only 6 lights on J2 are actually used on the back glass. The rest must go somewhere else, and there is a little table down here at the bottom, this table B, that is labeled panel to back cabinet plug. I'm not exactly sure what that means, but I'm assuming that, and these are all of the other wires that aren't used on the back glass, so they must have added like a daughter plug on or something to take some of the signals that would have gone up there and taken them back down to the play field to use. So back on my table here, I marked in pink all of the lights that are on the actual back glass, and the rest of those somehow get down to the play field. I'm not sure how that used to happen. For me, it doesn't make any difference because we're going to be sending it out to the LED string anyway, so this connector is no longer used and we don't really have to worry about it. But just to show you what I'm doing right now, these are all of the signals that Bally is sending out. So somewhere there is a spinner bottom, and I have to find out what that is over here. I don't remember anything like that I would have named, so I'm going to skip over that one for now and go to the next one. Well, spinner 5 top, I'm going to let that go too. Left side spinner 100. Okay, that one I recognize. So left side spinner 100 is 38. So I just put a 38 in there. And whoops, not there. Left side spinner 100, 38. Saucer G is 2. Saucer E is 6. And so on and so forth. I mean, so once I've filled in all the ones that are obvious, it'll be easier to figure out the ones that are left, which ones I need, where they go. And so I'll bring you back in just a minute when I have this all filled in, and I'll show you what it looks like. So really quick to wrap this up tonight, I have finished laying all this out. After I marked in the index column all the ones I absolutely knew what they were, I went over to the right here and I highlighted all the ones that had been used, which left the 3 or 4 that I couldn't understand first time through, and it was obvious then where they went. So some have multiple lights, like the spinners are arranged in a V. So the first one only has one light, the one on the bottom only has one light. But then as the V goes up, there's 2 lights, one on the left and one on the right. So there's 2 separate LEDs that'll be needed to turn on for all of that. Probably one of the most interesting one is the left and right thumper bumpers are turned on with one signal. And for me, that's 16 LEDs that get turned on. So if that thing turns on, I have to run a little loop that turns on all 16 of those. So that should be an interesting little piece of coding. Same thing with the center thumper bumper. There's one signal that'll turn on all those lights. Now, at some point, we might add some interest to the game by animating those lights and making them spin or something like that. But you know, generally the first time through, we just try to do it the way the game used to play. So all the lights would just come on, and we sometimes when we do that, we'll turn the intensity of those bulbs down a little, just so that it doesn't overwhelm the whole play field when those things blink. But we'll see how that goes when we get there. So this is definitely going to wrap it up for tonight. I'm going to quit here. I think this is really a good stopping point. When I move this stuff to my code, it gets laid into the code in this Bally index order, because when the machine interrupts me with a number, I jump down into a table, I find a number, I find which LED should be being turned on, and I flip the on bit for that one to say this one is now on. And then later on, when the display driver runs, it goes through and it sees that 37 is on, so it turns it on. And I'll show you guys that in the code when I get around to updating the code. But I know this thing was kind of jumping back and forth because of the way I developed it. Sorry about that. I am done for the night. Thank you for watching. You guys have a great day.